In this session, we'll give our player something to pick up along the way, and some lives as a consequence to death. In the 2D character blueprint, let's set a variable for a score, and set it to an integer. Then find your begin play event node, drag off the isDead variable and set the score to 0. Next we'll go into our UI widgets folder and create a new widget blueprint to give us a display of that score. I'm calling it HUD. I can use this to give myself some feedback for testing, as well as a player interface when I publish the app. Open the blueprint and add a text block to the viewport. Let's just call it score. I'm adding one more text block for lives. Even though we don't have that variable set, let's just get it set up. You could stick both of these text blocks inside a box for alignment, but for now I'm happy to set the alignment manually and move on. Now add a text block next to score, so we can set it to the score variable. To set this to a variable on our character, let's create a binding. Within the binding blueprint, drag a pin off the Get Text to Cast to 2D Side-Scroller character to get the score value. Drag off the Object pin to get the score variable and just connect it up to the return node. This tells the UI widget to update that variable with whatever value is currently in the score variable. Now we need to adjust the 2D side-scroller blueprint to add this widget to the viewport. I'd like to reset the score to 0 when a level starts, so leaving the score set to 0 is fine for now, and we'll just create the widget HUD and add it to the viewport. Update the comment to include the score and give yourself a little more room. Drag off the set score node into a construct widget node and set the class to HUD, and drag the executable into an add to viewport node and connect the object pins. Let's make sure we can have something the player can interact with to increase that score. For that we need another blueprint of the actor type, so our player can interact with it. For this game I'm making a simple coin. Start with a cylinder and modify the Z-scale to make it more of a disc. Then just play with the rotation until it's what you want. I'm okay with a front-facing coin. Let's see what this metal material looks like. I'm not sure what this edge will look like in the game, but we can always change the material later. Remember to update the collision so the player can destroy it on overlap, just like our touch and win blueprint. Add an overlap node to the blueprint's event graph. Drag off the executable pin to cast to 2D side-scroller character, so that we can get the score variable again, and increase it by an amount. Then we'll set the score to score plus 15. Also connect up the object pins, and destroy the actor at the end. After placing a few of these across the level, we should be able to interact with them. Remember, the Z-axis needs to be zeroed out, and for some reason this material is black, like a black hole of nothing. The function is working, but I don't like this material. Changing it to yellow cube material works better for now, so I'm happy with that. That function is working well, so I can move on to the other systems we have planned. Let's add a few more coins to make the level more interesting while I test out these other functions. This is where you can start to get creative. These coins can go anywhere in the level. In order to store the lives variable from level to level, we need to store it in a game instance. This part is important and took me a while to find out. So mental note, if you need a persistent variable throughout the game, it's in the game instance, not the player character. Call it something that makes sense, like var storage. All it needs to do is store variables. We'll add a variable called lives and set it to integer. Click the eye icon so that it's exposed and expose on spawn. Save and close the game instance. Now we can get the lives variable and add it to our HUD widget blueprint. And for testing, I'll move it down a little so it's out of the way of the notification I get when entering the level. Add a text block here, and we'll simply bind it to the variable stored in the game instance. It's not the undo icon, it's the new binding button, but while we're still on this screen, let's set up this text block with a variable name that makes more sense. It's a good practice to be as descriptive as possible with your variable names. Score variable as a name is pretty clear compared to S1 or something like that. Now we can create the binding in a similar way, cast to var storage, get the game instance object, and pull off the lives variable and connect it up to the return node. Once you connect the lives variable to the return node, the engine will automatically convert it from an integer to a string for you. It's returning no value here, but I think I forgot to use the game instance in our project settings. From the Edit menu, find Project Settings. From the Project Settings, find the Maps and Modes settings, and at the bottom of this screen is the game instance. You could always edit the default game instance if you prefer. There we go. Now the last thing to do is to increase and decrease those life totals. To help with that, I'm adding a few more coins to the level so I can really up the score. For this game, I can add the function to the coin pickup, because it's a very simple game. However, if you have more than one pickup, you'll want to add this to the character blueprint, or else you'll repeat the same code for every blueprint, and that's just a waste of time. This part got a little complicated while I was trying to figure out how to add one life once my score total hit a certain interval. For that, I added a branch just before the coin is destroyed. Let's try this. If score is greater than or equal to 50, return true. If not, just destroy the actor. If true, let's get the lives total and add 1. Use an int plus int node, and for this project, adding 1 life is fine. However, this wouldn't work if you could add more than 1 life at a time. If picking up the purple raspberry, for example, awarded 200 points, this function would only add 1 life. Off the true executable in this branch, drag off to cast to var storage, and get the game instance for the object. From the var storage node, get the lives variable, and from the executable pin out of var storage, drag into set lives. Add an int plus int node to increment the life total by 1, and connect the var storage object to set the lives variable. Don't forget to connect the executable to destroy actor node. I test everything, so let's see how this is working out. After accumulating 50 points, I should see my life total increase by 1. And upon picking up the 5th coin, I have 1 more life. Success, for now. The problem with this function is that it will fire once my score hits 50, and give me 1 life for every coin I pick up after that. To correct that, let's add a variable that I can adjust independently of the score variable. Because this is the only pickup in the game, I can add it to the coin blueprint, but if I had more pickups, I would have moved it to the player. I'll make it a score counter that I can check before it adds a life. Rather than checking the score variable to see if it's at or above 50, let's get our new score count variable and connect it between the setting of the score and the branch. Setting it to be equal to the score isn't a great idea here because it will add 1 life every time it's picked up. Follow the true branch to the set lives node and drag the executable off to set score count. Get the score count here as well and add an int -int node, and enter 50 in the value to reset the score count after we award the player with 1 life. This reset function is nice, but the check to see if the player should be awarded 1 life still isn't working. Disconnect the score count from the set score node and get the score count variable instead, and hook up the int greater than node to the branch condition. For testing, I set the default value of score counter variable to 50. I wanted it to fire right away, but this great idea cost me a lot of time. At this point, the function will work if the default value is 0. If you make that change now, you can skip ahead. I will cover the solution I came up with, even though I did it the hard way. In this playtest, you can see every coin pickup is giving me 1 life. I got the idea to add a variable which would store the point value of 15 to the coins, so I can increment the score and score count separately. Remember, at this point, score count is still defaulting to 50. This setup will set the score count to 15 with every pickup. It will never be higher than 15. The fix was to set score count to score count plus the point total. However, the default value is still 50, so this won't work either. After this setup, I got the idea to add a score counter variable to the 2D character, which will effectively do the same thing, and it won't be set to 50, it'll start at 0. I then went back through the coin blueprint and replaced all instances of the coin. All instances of the coin's score count variable with a cast to 2D character to retrieve the second score counter variable. Once I replaced the variable, the math started working properly. This is how the blueprint is set up even in the downloadable version from my website. In this playtest, we can finally see the coins are counting towards our score, and we're awarded 1 life every 50, 1 at 50, and another at 100 points, just like we would expect. Give yourself more room in the blueprint that handles death. Find some room between the set visibility node and the delay. Drag an executable from the set visibility into cast to var storage. Get the game instance for the object, and from the executable set the lives variable. From the asvar storage pin, drag out get lives, and drag from get lives to an int minus int node to reduce lives by 1. And now we can see the lives total is decreasing by 1 when the player dies. Up next, a timer and starting level screen.